Bismillah ar-Rahman ar-Rahim. Today we will discuss temperature. This is the first slide. The upper part shows the the difference between the mercury thermometer, the Celsius thermometer, and the Fahrenheit, where the 0 point is corresponding to the 32 Fahrenheit, and these are the 4 grades of measurement of temperature. This is the first time to hear about the ranking, where the 100% of the 100 degrees Celsius equals 672. So the most important is the Kelvin, of course, and the Celsius and Fahrenheit. Now we come talk about the non-electrical thermometers. This is the boarding gauge, as we can see. We will explain later on. It's made of a hollow tube with a sensitive material. When it is heated, it activates the pointer on a scale, and this is the bimetallic strip, where we have two metals attached to each other in a strip. Each of them have a different coefficient of thermal expansion. Whenever they expand by heat, of course, they expand in an equal degree, activating a pointer on the scale. And then we have electrical thermometer. This is the platinum thermometer, and this is the thermistor. We will discuss later on about it, which is made of a head of a nail, as you can see. And then we have the thermocouple made of two different types of metal. So these are the 3 main non-electrical components. And then we have what we call the pyroelectrical electricity, or the optic thermometers. One of them is the pyroelectrical, based on the bioelectricity. It depends upon the ability of certain materials to generate a voltage whenever they are subjected to heat or cool. And then we can see it is made of a ceramic crystal and electrodes on both sides of it, creating a capacitor. Whenever infrared falls on it, it releases electricity, which can be estimated. And then the second type of the optical thermometer is the thermopile, where it's made of many thermocouples, as we will be seeing later on. And this is also a figure showing also the optical thermometer used to measure the temperature in the external ear with a tube. And we can see the shutter button, but this shutter button close and off several times, preserving energy, and at the same time it increases its accuracy. And later on we'll tell what's the advantage of the emitting instead of absorption light. And this are the method of heat loss. Conduction, of course, is very little. And then we have radiation, which is very important, radiant rays arising with the patient. And then we have evaporation, especially if there is sweating. And then we have convection. And then, of course, from the respiration, we lose heat. And this is the 4 main methods for tissue to lose temperature or heat. Of course, I'm not going to discuss the difference between heat and temperature. You can read about it. Temperature scale, of course, the systemic international system is made of Kelvin, which equals 1 over 273.16 of the thermodynamic temperature of the triple point of water, where the 3 forms are present and in equilibrium in pressure: gas and liquid and ice. And of course, we use the capabilities of some materials to utilize it to function thermometers. Of course, mercury expands whenever it is heated. The triple point of water equals 0.01 degree, not 0.01 degrees Celsius, you see? So first of all, we will discuss non-electrical techniques for of temperature measurement. Of course, we know the mercury thermometer. Where we have a constriction to prevent the easiness of descent of the mercury whenever I reach the upper limit after equilibrium after 2 to 3 minutes. And whenever I want to make the mercury turn back, I must shake vigorously. And this is another form of mercury thermometer where there is an index. This index, its advantage that it is being held left aside after the descent of the temperature, so we can have a residual reading of this temperature. Of course, this mercury thermometer are easily to be broken, so this carries problems whenever I use it. The second thermometer I can use expansion is the alcohol thermometer. The advantage of it is that can read very low temperature because it solidifies at -39. Of course, remember this figure because it boils at 78.5. So this is the double of this figure, but this is negative and it's positive. This is the boiling point. This is why it cannot be used for high temperature. At the same time, the scale is not linear, so much linear as the mercury thermometer. The second type is the dial thermometer. This is the dial thermometer where we have two metals of different coefficient of thermal expansion that are held together. So whenever I heat, one of them is going to expand more than the other. So it will activate the pointer on the scale reading the temperature. The second type is the boarding gauge, and this is the second boarding we had mentioned. The first of all was for a pressure where there is a tubing system and a sensing element, whether it's mercury or a volatile. Whenever a volatile acid, a volatile substance, whenever it's heated, it expands, it tightens, and then it activates a gear system and a pointer on a scale. These are the two other types of the non-electrical thermometer. Electrical thermometer, we have three types. We'll show them later on. We have the platinum thermometer, we have the thermistor, and then we have the thermocouple. The platinum thermometer is made of platinum wire. It has an ammeter and it has a battery also in it. It is shown in the first slide. It's not used much in anesthesia. It's used in industry. The thermistor is a small, very small bead of oxide of metals. This bead, whenever it's heated, its resistance increases proportional to the temperature. You see, so though there is another types where it can increase by the resistance increases by heat in this type of thermometers. You see. So this advantage of it that it is easily to be decayed after heating during sterilization. The third type is the thermocouple. Thermocouple is based on that whenever two metals are attached to each other, they create a voltage. So we have suppose copper and constantan. Constantan is an alloy of copper and nickel. Whenever they attach to each other, they create a voltage. This voltage can be utilized to measure the temperature. So we must have a measuring probe and a reference probe. This reference probe, as if it is being put in ice so that it will be fixed at zero. Electronically, of course, by electronics, of course, there is a potential developing at this point. So electronics can fix it to make it a reference, you see. This is what we call the thermocouple, made of two couples. Of course, it can be made as a very small needle. Of course, the heat capacity of it will be very little, so that it response will be very rapid from 0.1 to 0.15 seconds. Of course, the thermistor is a small bead which can go through cavities of the body, measuring the cardiac output. This is the advantage of it. We will show you the pictures of these instruments. This is the picture showing the resistor decreasing by the thermistor and the resistor increasing the platinum thermometer. And this is the thermocouple, two metals attached to each other. One of them is a reference fixed, and the other one is used as I'm sorry, this is the reference and this is the measuring, and then this is the potential whenever the temperature increases. Clinical techniques of temperature measurement. Clinical applications, clinical application, of course, mercury thermometer, as we said before, it's easy to be breaking, especially in infants, so it's not used much in the theater because it's rigid. Richter thermometer in adult takes a longer time for equilibrium, so it's not much use, of course. The most one which is used is the thermometer or the sensor present in the lower esophagus. Must be in the lower, not too high, because if it is too high, it will be affected by the temperature of the respiration and will affect the final result. Of course, we can use in the nasal route as a temperature, and also as a designed for respiratory monitor. Of course, during expiration, the difference in temperature can be utilized to measure the respiratory rate. Of course, the nose can be used also as a source of site for measurement of temperature, especially if the patient is intubated. Skin temperature is very important, especially in shock patient where there is a discrepancy between the core and the skin temperature. And we have a special measuring of the skin temperature based on the thermography. Thermography, it is a device where by special means of cameras can sense the heat of the object by the radiant heat arising from the patient, and it can show vascular areas in the human being and areas where there is the possibility of tumors. The other type of thermometer is the optical thermometer. We have what we call the infrared ear and tympanic membrane. We have, of course, one of them is, as we showed before, that is a special tube being introduced in the external ear, where the infrared emitted from the hot object of any person is being utilized by this device, where it can transfer this heat into electricity and shown on the screen. We have two types. We have what we call the pyroelectrical sensor, and then we have the other one which is called the thermopyre. A pyroelectrical sensor used to measure the tympanic membrane is being introduced to the tympanic membrane. Of course, it can induce perforation. So it is a good one to represent the core temperature, where infrared rays at a special wavelengths in the spectrum of light will be released and then sensed by a ceramic slide, where two electrodes are being attached to this ceramic, comprising or making a capacitor. You see, this voltage changes can be sensed by the temperature and recorded as temperature. There is what we call polarization. Polarization, it is as if the charge of the molecule are separated. So we have two poles, a positive pole and a negative pole. You see, so as if the molecule has two poles. So whenever they are affected by infrared rays, their direction will be affected, creating a voltage which will be sensed as a temperature. Of course, we have a shutter mechanism. This shutter mechanism gives less amount of on and off light to be sensed by this ceramic, of course. And then the point is that the device does not absorb the heat, but the light, I'm sorry, but it is exposed to it. So the response is very rapid. You see, whenever we have something that is sensed not by absorption, the response will be rapid. The last slide. Of course, the human being are most of the animals and the birds are homeothermic. They keep the temperature irrespective of change of the atmospheric temperature. And of course, we have all these are some informations if you want to have a hint about it. Of course, we have a circadian change of temperature during the day, and of course, we know the menstrual cycle, and of course, the exercise increases the temperature. The central core temperature includes, of course, the brain and thoracic and the abdomen and deep tissues. And the shell is the area separating the surface from the core. It's around 2.5 centimeters, which is at a temperature of 30, suppose less than the 37, around 32, 34, and so forth. The heat production, as we all know, it's around 80 watt or 50 watt per square meter. Of course, the shivering is sometimes it's very difficult to be seen whenever it's mild. It can be recorded by electromyogram, which is a method to increase heat production. And these are the methods of heat loss, which is important to memorize. We have the radiation, and we have the convection, and we have the evaporation, and we have respiration. The first one, it's 40 to 50, and then 30, 20, and 10. You see, these are the figures you must memorize. As regard respiration, 10 of this 8% of this 10 is being used for humidification of the dry gases, and the 2% is used to increase its temperature. Humidification, of course, increases from 50 to 100%. The heat loss, first of all, is conduction, means you must have a conduction between you and the object where it can transfer. It does not make much of the heat loss. The most important is radiation, as we said before, from 40 to 50%. Radiation is any hot object releases radiant or radiation of electromagnetic waves with a special waveform, losing temperature. Of course, when the surroundings are cool, this will hasten the loss. And if it is covered by the aluminum foil, made sometimes of metallized plastic foil to decrease the heat loss, especially in kids. Of course, this is liable for burns and electrical current. Caution. You see, this is the drawbacks of it. The convection current loss is simply the heat surrounding the patient. The heat surrounding the patient is being heated, taking heat from the human being. So whenever this area is heated, it will be less dense and it will elevate it. So it will be replaced by another area of air will come and take the heat and so on. So you have to have this is some sort of conduction. This is what we call conduction heat loss. The third type is loss through the skin, especially sweating. Sweating increases the heat loss by 10 times. And then, as we said before, the loss through the respiration, whether to humidify the respiratory or dry gases, or to warm them. And these are some information if you want to have a hint about it. What's the mean? What controls the heat? Of course, the hypothalamus and the skin, and vasodilatation, effect of anesthesia on the human being. The vasodilatation loses heat, And then whenever I decrease the temperature at 30, the patient can tolerate hypoxemia and arrest for a longer time. This is being used, of course, in open heart. Beyond the 30, it can induce the ventricular fibrillation. Of course, we can never miss the malignant hyperpyrexia, in which the patient is subjected to such an incident if he is exposed to hallucin and succinylcholine choline. It's an easy chapter. The most important thing is to know the methods of measurement temperature, whether it is non-electrical or electrical, and the optical types of measurement, and the way how the patient loses heat. I hope that I succeeded. I'm doing my best. Wassalamu alaikum wa rahmatullah wa barakatuh.